data. Data which are collected for the first time for a specific purpose are known as primary data. For example, population census, national income collected by government, textile bulletin, RBI bulletin, which is collected monthly. Next is two important uses of index number. Number one, measurement of change in price level or the value of money. Means index number can be used to know the impact of the change in value of money or different sections of the society. Number two, adjustment in salaries and allowances. Cost of living index number is useful guide to the government and private enterprises to make necessary adjustment in salaries and allowances of worker. Number 3, relationship between mean, median and mode. The relationship between mean, median and mode is 3 median equals to 2 mean plus mode. Number 4, cost of living index number. Cost of living index number generally represent the average change in prices over a period of time paid by a consumer for a fixed set of goods and services. It measures the relative changes over time in cost level required to maintain similar standard of living. Number 5, you will be given a number for which you have to calculate arithmetic mean. Like for example, arithmetic mean of 2, 6, 8, 10 and 15. So as we'll know that mean equals to sigma x by n, so sigma x equals to 41 and n is 5, so 41 by 5, that is 8.2. So our arithmetic mean will be 8.2. Factors responsible for trend in time series. 4 components of time series are secular trend, which is represented by T, cyclical variation, which is represented by C, seasonal variation, which is represented by S, and irregular variation, which is represented by I. These are the 4 components of time series. Number 6, examples of seasonal variation in time series. Number 1, sale of woolen clothes during winter, decline in ice cream sales during winter, demand for TV during international games, demand for tea during winter, and demand for cold drink during the summer seasons. Number 7, coefficient of range. Coefficient of range of 5, 7, 8 and 15. In this you will get a number for which you have to calculate coefficient of range. So as we know that range equals to highest minus lowest upon highest plus lowest. So here 5 plus 7 plus 8 plus 15, that is 35, and the highest is 15 and the lowest is 5. So 15 minus 5, that is 10, and highest is 15 and lowest is again 5. So 15 plus 5 equals to 20. 10 upon 20, that is 0.5. So our range will be 0.5. Number 8, why Lorentz curve is used. The curve was used by him for the first time to measure the distribution of wealth and income. Now the curve is also used to study the distribution of profit, wages, turnover, etc. Now the curve is also used to study the distribution of profit, wages, turnover, etc. Number 9, you will be asked for when the correlation coefficient is negative. So the answer is correlation is said to be negative when two variables move in opposite direction. Similarly, correlation coefficient is positive when correlation is said to be positive when two variables move in the same direction. Then the correlation coefficient will be positive. Next is a 3-mark question. Prove for any two non-zero values that AM is greater than or equal to GM and GM is greater than or equal to HM. When do they become equal? Here, let two numbers be x1 and x2. Therefore, arithmetic mean of x1 and x2 equals to x1 plus x2 by 2. That is arithmetic mean. And therefore, similarly, geometric mean of x1 and x2 equals to x1 into x2 to the half square, which means x1 into x2 root root x1 into x2. That is geometric mean. Similarly, harmonic mean of x1 and x2 equals to 2 upon 1 by x1 plus 1 by x2. That is harmonic mean. Now, by taking AM and GM, we get root x1 minus root x2 to the whole square is greater than or equal to 0, which means root x1 whole square minus root x2 whole square minus 2 into root x1 into x2 is greater than or equal to 0, which means x1 plus x2 equals to 2 into x1 root x1 into x2, which means x1 plus x2 upon 2 is greater than or equal to root x1 into x2. That's we prove here. We prove a arithmetic mean is greater than and equal to geometric mean. Again by comparing geometric mean and harmonic mean, here 1 by root x1 plus 1 by root x2 to the whole square is greater than or equal to 0, as we can see this, which is equal to 1 by root x1 to the whole square plus 1 by x2 to the whole root x2 to the whole square minus 2 into 1 by root x1 into 1 by root x2 is greater than or equal to 0, which is equal to 1 by x1 plus 1 by x2 is greater than or equal to 2 upon root x1 into x2, which is equal to root x1 into x2 is greater than or equal to 2 upon 1 by x1 plus 1 by x2. Hence we prove that geometric mean is greater than or equal to harmonic mean. So from 1 and 2 we got AM is greater than or equal to GM, and here GM is greater than or equal to HM. So from 1 and 2 we got arithmetic mean is greater than or equal to geometric mean, and geometric mean is greater than or equal to harmonic mean. So hence it proves. Question number 13. Calculate the missing frequency for the following data. Given arithmetic mean equals to 24. Here class interval is 0 to 10, 10 to 20, 20 to 30, 30 to 40 and 40 to 50. And frequency is given 5, 25 and a dash, that is we will take it as F3, then 18 and 7. So sigma F equals to 55 plus F3, that is summation of all the frequencies is 55, and we have F3, that is F3. So from CI we class interval we calculate mid value, that is X. So here 5, 15, 25, 35, 45. Now we have to calculate D. D is x minus a. D is x minus a. So for a we have to summation of x upon n. So summation of x we got 125 and n is 1 2 3 4 5, n is 5. 125 by 5 equals to 25. So a will be 25. X minus a, x's are this 5 minus 25 minus 20, 15 minus 10, 15 minus 25, that is minus 10, 25 minus 25, 0, 35 minus 25, 10, 45 minus 25, 20. So sigma d will be 0. Now FD is frequency and D. 5 into minus 20 minus 100, 25 into minus 10, 2 minus 250. F3 into 0 is 0. 18 into 10 180, 7 into 120, 7 into 20 140. So sigma FD is minus 30. 350, 350 and here 320. 350 and 320, that is minus 30. Sigma summation FD is minus 30. Mean equals to a plus sigma FD upon n. So mean we have arithmetic mean is 24 and equals to a is our 25 plus minus 30 sigma fd is minus 30 and upon n is 55 plus f3. 24 minus 25 equals to minus 1 equals to minus 30 upon 55 plus f3. Minus 1 into 55 plus f3 equals to minus 30. Minus 55 plus minus f3 equals to 30. Minus 55 plus 30 equals to f3. So minus 25 equals to f3. So hence we have f3 equals to minus 25. So the missing value frequency is 20 minus 25. The requisites of a good measure central tendency important properties which is a good average should satisfy. It should be easy to understand. It should be simple to compute. It should be based on all items. From the data given below, calculate the value of standard deviation by using the method of least square. So we have frequency 12, 18, 16, 14, 12, 8, 6. So n equals to 86, and class interval 32, 32, 32 to 34, 34 to 36, 36 to 38, 38 to 40, 40 to 42, and lastly 42 to 44. So we have to calculate the mid value. So mid value x 31 to 32, that is 31, 33, 35, 36, 37, 39, 41, 43. So summation of mid value is 258. Next we have to calculate d. So d is x minus a. So we have to calculate a. For assume mean, we have summation x is 258 and n is 1 2 3 4 5 6 7. 258 upon 7 equals to 36.8. So let assume mean be 36.8. So greater value is 37. So we will take 37 a. So 31 minus 37, say minus 6. 33 minus 37 minus 4. 35 minus 37 minus 2, 0, 2, 4, 6. So sigma d will be always 0.